Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels on LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Well, thank you all so much for joining Did You Know? The ESCO HVAC Show. I know that there are times where I might sound like the bell ringer of the apocalypse when we start talking about technology and the way things are changing in our industry. But it's for a very important reason. It's because I care about this industry and I care about you. And I am here to help prepare you in your classrooms and as a technician and as a student for things that are happening in our industry, not years down the road, but literally in a couple of months. And as an industry, we're just not very well prepared for the things that are going to happen. So we've talked over the last few weeks a little bit about communicating HVAC systems, particularly those that are using the 5-volt DC platform, and where we can easily troubleshoot diagnostics on our networks. We talked a little bit about changes in fan regulations. We talked some about A2L refrigerants. We have mentioned some of the SEER2 requirements, but we haven't really dove into what exactly that looks like. And that is because a big part of our industry hasn't really been showing exactly what that SEER2 is. Because I'm telling you, after today, you're going to look at SEER2 with a different perspective, and you're going to go, okay, that's not what I was expecting to happen. I know everyone's been saying that it's going to happen, but I didn't really expect it to happen this fast. It's a monumental change, but it's really not major things when we look at industries overall. If we look at what's happening with the HVAC industry, we can very much compare it to what has happened in the automotive industry for a couple of decades. If we look at energy efficiencies of automobiles and the technologies that have changed in them, we have had a very significant increase not only in the efficiency, but on the output of our internal combustion engines. Now, when we look at the HVAC industry, we've made some changes on our internal compression engines. Remember, our compressor is just a vapor pump driven by a motor. It's an internal compression system, but the efficiencies have not been driven anywhere similar to what has happened in the automotive industry. Now, the automotive industry, they didn't revolutionize their entire industry. They didn't completely rework the internal combustion engine. They did a lot of modifications, particularly in the way that we control our internal combustion system. So we went from carburetors and points ignition and chain timing systems, mechanical components, over to things like fuel injection, electronic ignition, and variable valve timing. So the core of our internal combustion didn't really change. We just changed how we can manipulate the system to become more efficient. And we've been very successful at that. If we look at the HVAC industry, we are going through this revolution, and we hope that you're going to be prepared for that. We will be moving away from things like fixed orifices and contactors and single speed motors and compressors, going to new technology like thermostatic expansion valves, electronic expansion valves with control boards, and variable speed components in our motors and in our compressors. That is the reality of the world that we're going to be facing. So as students and technicians and educational facilities and institutions, we need to make sure that we are prepared for this, because you are going to become a new type of technician in the next few years. If we look at automotive technicians, an automotive technician relies on the internal components of those new systems to be able to do diagnostics and commission and be able to tune and tweak things, right? Same thing with us. We're going to be utilizing more technology that is already built into a lot of the equipment to be able to do self-diagnostics and be able to look at troubleshooting and things that we have been utilizing in the commercial and industrial environment for a long time, but not really in the residential. It's going to happen now. And it's going to have a fund driven behind it that's going to encourage the country to start upgrading into new technologies. So not only are we talking about equipment replacements for failed systems, we're going to be encouraged to upgrade equipment into higher efficiency systems, moving away from our legacy mechanical systems. Now, you will hear a lot of things about the Inflation Reduction Act. And one of the big things that stands out is a $4 billion piece of that is going to be going for energy renewable products in the HVAC industry. But just today, we had a new release from the U.S. Department of Treasury talking about the big umbrella of energy and climate change that is coming to America. We're talking about $369 billion going towards climate change investment over the next decade, the next 10 years. And a lot of that is going to be focused on inefficient components within our space. A big one is us. And so that's what we're going to do today. We're going to dive a little bit deeper into what this means to you, what you're going to be seeing going forward, and give you the opportunity to be well prepared for these changes. So thank you for joining us. And David Brannon from Rheem, man, we are excited to have you here. And we're very blessed to have Rheem on the forefront of educating our industry with what these changes look like. So David, thank you for joining us. So what are we going to get into today? Where do we even want to start with this?
Hey, Clifton. Yeah, great to be here. I'm happy to help. So we're going to talk about kind of where the M1 regulations are taking us as a company, what we're doing with our equipment, what that's going to look like in the industry. And,
Yeah.
one of the big changes that we're facing here is in the South, at least where I'm at, I live, in the middle of Texas. And, basically January 1st, 2023, you can't sell an air conditioner that's not rated with the SEER2 tag on it anymore,
Isn't that
period.
crazy? This is not we're going to change our equipment. Let's spend another year or two to sell through what we have. This is done. This is a
Right.
new
It's
start
written
for
as
a
an
new
install
generation.
date.
That's exactly right. And that is one key that gets left out of a lot of conversations. When we were talking about our transitions away from R22 coils and R410A coils, there was still equipment availability. There were things out there. We're not going to have a similar scenario when we start getting into our SEER2 stuff, are we?
Nope. And it doesn't really stop there. So, as soon as we get done with this Tier 2, we're going to be looking at a refrigerant change away from 410A. They're revamping the Energy Star right now. So that's going to change a lot from the municipality standpoint. Building code is all fixing to get rewritten for the A2Ls. And
That's
then
right.
electric companies are looking at demand response. And, you got the big D word out there, decarbonization.
Man, first couple of times that I started talking about decarbonization and electrification on this particular program, boy, I got a ringer from some educational institutions and some management within that didn't really want to talk about that yet. And if we're not ready to talk about it, you're going to be. So very, very good topic to hear from our manufacturers.
Yeah. Um, we're not going to get into that today, but
No.
the big change that we've got going on right now is the M1 standard. So that's a testing standard written by
Right.
ASHRAE. And the big change that's dropping the efficiencies down is the wattage. So
Yeah.
we're going from 365 watts per thousand CFM to 441 watts per thousand CFM, and a total external from point 0.2 to a total external 2.5, which, realistically is
More
still
realistic.
lower
It's
than what
still
we
low.
see. Yeah.
Oh, absolutely. I've always said in our industry, point 0.5 is difficult in the Midwest. So there are many places in the country that point 0.5 is rarely realistic, even on brand new constructions.
Yeah, the industry here has been, flex duct and duct board for
Forever.
a good 10 years, maybe
Yeah.
15. And you're not going to, you just don't see them installed at point 0.5. So,
Very, very rarely. I've seen many well above 1.0 on new installations and done site
yep,
visits, exactly like you've been doing today. Going
yep,
out to look at a piece of equipment and go, well, it can't perform when it's outside of these parameters. So a much different parameter set to work with.
yep. And then, like we discussed earlier, the federal north map and the heat pump map, what we'll mention here, is all based on a manufacturer date. So the gray states, if it's an air conditioner, it can be sold as long as it was manufactured before December 31st. But in the red states down below, the south states, southeast, southwest, all that is written on an install date. So that
Right.
means, if it's not SEER2 rated, December 31st is the last day that you can install it, register it, period.
Wow. It's going to play a lot of change on our distributors as they start relooking at allocating equipment into other sectors. So it's not something that is just affecting the technicians on the ground. This is something that's affecting an entire industry from manufacturing to distribution to a piece of equipment on the ground that a technician has to look at and go, can I even install this in my area? Big
Yep.
changes.
Yep. So we've got distributors. Our last order date for M product was probably 4 months ago. So whatever
Oh,
they ordered then, they'll get
that was it.
if it's built by December 31st. And
Sure.
if it's not, then, the simple reality is, you're basically taking something that would rate 15.5 to 16 SEER today, re-rating it if you were going to do that. And it would be, 14.3 SEER2 is,
Sure.
and now you've got what a high efficiency piece of equipment now being called entry level.
Yeah, exactly. And that's the big change. When people first started talking about SEER2, the philosophy was, oh, well, it's only going to affect certain pieces of equipment, not realizing this is changing our entire equipment matchup. This is not where we're just going to make things a little bit more efficient. This is an entire matchup from manufacturers are going to have to be realigned and have new match and new ratings.
Yep. So here we're talking about the minimum efficiency. So I mentioned earlier 14.3. So in the southeast, where I'm at, in the southwest, 14.3 is the minimum SEER2 rating for a piece of air conditioning equipment, up to
Mm-hmm.
45,000 BTUs, and then over 45,000, it's 13.8 SEER2. And then if you get into the southwest, you're also tied to a minimum EER2 efficiency,
For
and
heating
then
efficiency.
HSPF2 for heat pumps.
Wow. Pretty significant increase over what we've worked with in the past.
Yep.
So, what is M1? When we start talking about M1, there's going to be a lot of people asking questions about M1 and how it affects SEER2.
So it's a testing standard. So the equipment today is tested to the M standard, ASHRAE
Mm-hmm.
M standard, and then M1 is just the first revision of the M standard. So it's how the piece of equipment is rated, which gives you a SEER rating with M and a SEER2 rating with M1.
Okay. So, we're just adapting some testing procedures that we've had, and we're now just setting a new updated standard for it.
Correct.
Okay.
And then the heat pumps aren't affected as hard. Now, we're not going to continue with our product line because we changed a lot of stuff with this new product line to get ready for the A2L changes. So even on heat
Sure.
pumps, our last order date has already happened. So on current heat pumps, and then the new heat pumps and the new air conditioners won't match the air handlers and coils that we're using today with the M product. So
Exactly.
even though you could sell that heat pump past January 1st of 2023, it it's buy them while you can get them.
And it's more so for just a retrofit application. If we're just changing an outdoor unit, now we've got a piece of equipment that would still match up with our existing coil. May have an uncertified rating, but at least it is purchasable for a replacement.
Yeah, and the law is written, and it's going to be up to interpretation, but the law is written to say that a system is rated at SEER2, not a piece of a system. So
Exactly.
technically, it is telling you that there's not going to be any more changing a condenser.
And that's what I've been looking at a little bit deeper. And I didn't want to dive into that without being clear on it. So I really appreciate that because that's what I see. I see a system and not just an individual component. So that's probably a conversation to dive into on a later date because that opens up a lot of interesting topics in itself.
Well, you got to think about it from a system standpoint as well. You're not going to take today's 16 SEER condenser and put it on a 10-year-old evaporator and expect it to run very long. It just isn't.
Exactly.
So that's another driver where this is going to make it to where you're going to put a system in. It's not going to be a piece of a system. And while you're talking about a system, it's also going to include making sure the ductwork matches what you're putting in.
Yeah. Yeah. So a lot of things that we've known should be done on a system and have up to this point been able to pass because they weren't new laws, new codes and requirements. So as we move into system codes and system matchups, we're going to see a lot less equipment replacement and now more system replacement. Yeah.
So this slide here is talking about, the options that you had as a manufacturer. So you had to make something rate SEER 2. So the option are obviously you could increase coil size and get a higher SEER rating, but the equipment's already so big that really isn't a realistic option. So
Mm.
for us, the option was to go ahead and re-gear for the A2L change, which effectively gave us more matchups because we're not just re-rating equipment that was already rated in a SEER rating. Plus, it allowed us to shrink our mid-tier stuff. Our 15 and 16 SEER2 rated equipment is now being built in a 13 SEER rated cabinet. So it's shrinking in size instead of getting bigger.
Okay. All right. So that brings up some good questions about sizing because that's always a fear when we start talking about new changes. Are we getting larger? Are we getting smaller? Are we going to horizontal discharge versus vertical discharge? So a lot of factors go into that. That really just kind of depends on the efficiency of the equipment once it gets to that matching, that qualification done through engineering. So
Yep.
very, very cool to see that.
So the big key here is how we shrunk the condensers is we went to a different size tubing. So instead of going to micro channel like you see some of the other manufacturers going
Right.
to right now, we go to a 7 millimeter diameter steel, copper, and aluminum tube and fin coil, but 7 millimeter tube versus 3/8 tube on the outdoor.
On the indoor, are we still?
Staying
What are
with
we doing there?
3/8 all aluminum, aluminum fin, aluminum tube on the indoor, still
Okay.
3/8,
So
but
good.
it'll be different matchups than we're using today.
Gotcha. Okay. Because that's one of the things that I've seen a little bit of is going from 3/8 to 7 millimeter on the indoor, but it typically does depend on whether we're using copper or aluminum because we're really looking for high capacity. We start looking at a large outdoor unit, we still got to get our capacity, our heat transfer through the indoor coil. So
Yep.
good to know. Those are still staying 3/8.
And then you're going to see a lot more, variable speed equipment. So two stage or inverter driven. Here it's showing you that some of our SKUs, about 30% of them are going away from scrolls and towards a twin rotary design,
Hmm.
which gives us higher efficiencies and more capability to vary the speed of the compressor.
Okay. Yeah. So we're getting a little variety of capacities off from going into that twin chamber rotary.
Yep.
Okay.
And then more communication. So this pushes communicating systems down into the 15, 16 SEER2 level for us. And
Wow.
then obviously the 18 SEER2 stuff is full communicating.
Sure. Yeah, that's a big change because typically, in the past when we would see communicating, we're talking about 17 to 18 SEER and above only, not typically in our mid SEER equipment. So, we've seen that that was going to happen and to be able to know that now it's going into that mid tier. That was one of the reasons that we were talking with EWC a few weeks ago. So, if anyone is not very comfortable with communicating systems, definitely go back and spend a little time with John Brown on our communicating zone control systems built by EWC that works on a 5-volt DC platform because it really gives you a better understanding of that network because we're going to see a lot more communicating stuff this next year.
Yep. So, I mean, realistically, you're going to see more manufacturers do this because you just can't hit the efficiency metrics that we're being asked to hit without having full control of your system.
Exactly. Which I'm fond of. I know I'm the weird guy out there that I love having these controls. I mean, we could spend an entire conversation talking about why we're using pressure transducer, 5-volt DC pressure transducers, and temperature thermistors on our equipment. And it's very much about creating an atmosphere where we can control that capacity. And when we talk about communicating systems, man, now we're talking about the ability to tap into a communicating system, which is the world that I love. I love getting into automation. So big, big steps in our residential world to see that.
Yeah, for sure. It's going to make it easier
Yeah,
and faster in the future, but it's going to be a pretty steep learning curve for some technicians out there. And then
exactly.
we've gone to a complete independent design board. So all of our boards are Rheem designed, and we're having board manufacturers make them, which is going to allow us to expand this technology into
Sure.
other products. So if you look at our lineup, we'll even have a couple of residential package units that are communicating.
Yeah. Wow. So that has been another thing that I wanted to dive into. I will have to pick your brain on that one because a lot of people have been talking about SEER2 and how it's affecting residential, and a lot of the thoughts have been, well, it's not really going to affect the light commercial side very much, but I knew that it would. So yeah, we need to definitely regroup on that one sometime because that is
Yeah,
a
so the
game
laws are
changer.
written not so much residential versus commercial. It's written
Mm,
as under 6 ton and non three phase.
exactly. That applies to a lot of light commercial installations.
Yep.
Cool. So what about our DC brushless motors? I'm really intrigued with that one.
So all of our communicating systems, so we've gone to a brushless DC permanent magnet motor, and a
Mm-hmm.
board or a drive is controlling it. And one of the reasons that we've gone this direction is supply chain, right? We're having a lot of
Yeah.
problem getting parts to build units. And if you go to a brushless DC motor, multiple vendors make a motor like
Oh
that.
yeah.
And really the only thing that changes is a torque curve. And so you
Mm-hmm.
just program that into the board, and you could easily move from one manufacturer to another, allowing us to diversify the supply chain.
What a great move. Brushless DC is just the way to go. So yeah, kudos for that.
You also get rid of the end bell on there, which is typically
That's
your
right.
problem with an outdoor ECM.
Now, and we get better airflow. We're talking about blower style. Now we have less space that our air has to travel through for the blower compartment. I mean, yeah,
Yep.
I love our brushless DCs. Nice. Lots and lots of new things coming in just a couple of months. All right.
So we're getting to the equipment line up here. So,
Mm-hmm.
that RA13NZ down there at the bottom, that's a northern unit. That N stands
Only.
for north.
Right.
Can't sell it in the south.
Mm-hmm.
So really the entry level piece of equipment that we'll be looking at in my territory is the RA14AZ.
Yep.
And interestingly enough, that will be our only single stage offering in the whole platform.
So this is what we need to have these conversations for. A lot of people don't understand that. When I put out my first post that contactors were going away and that single stage compressors were no longer going to be something of interest, a lot of people really shrugged that off as we're going to find a way to do that. But in reality, we really have to get into multi-stage and variable capacity to be able to meet these requirements.
Yep. Yeah, you're not going to do it with contactors. So that RA14AZ, it's a PSC outdoor motor up to 4 tons, an ECM outdoor motor on the 5 ton. So it will be running on a contactor. But to say that you could sell it completely and stay out of the other technology that we're using is probably an unrealistic goal, because we
Right.
have an air handler and a furnace that are both communicating that could control that outdoor unit.
Sure.
So even in some matchups, it wouldn't be straight non-communicating, even though for the most part it is.
So it's really a builder grade style unit.
Yep, completely builder grade. Yep.
Yeah.
But even still, if you were to compare it to something today, you're talking about a single stage 16, which makes it a little less forgiving on an install perspective than, what you're calling a 14 SEER today.
That's exactly right. Wow.
And then you go into the 15 and 16 SEER mid-tier inverter systems, and those are our mid-tier offerings, and they are inverter-driven twin rotary compressors with a inverter drive-driven BLDC fan motor.
And so this is the sweet spot. When we start talking about HVAC salespeople, your 15 to 17 SEER's always been the sweet spot in the industry, and it's going to continue. So now what we're looking at is we're not talking about two-stage 15 to 17 SEER equipment. We're talking about
Nope.
inverter 15 to
Yep,
16,
full
17 SEER
inverter
equipment.
driven equipment. Now these two will run on a legacy thermostat, like you see over to the side. It'll run on a
Okay.
two-stage legacy thermostat. But when you do it that way, the outdoor unit is still communicating. So you still got
Right.
E1, E2, R, and C going to the outdoor, and you lose functionality using a translator on a mini to its three-stage system. Is going to give you less system part load
Yeah,
condition.
absolutely. So there again, a lot more communications going into our future systems.
And then the 18 SEER2 stuff, so that's full-blown modulating variable speed inverter-driven scrolls, BLDC outdoor, communicating only.
Mm-hmm. Wow. Very, very interesting. So the only pieces of equipment that can function non-communicating are going to be our mid-level, mid-grade equipment and down into our basically our construction package. So
Yep.
what do you estimate? Do you have any ideas? Have we thought about an estimate of what the total percentage of equipment for 2023 is going to be in the high, mid, or base range? Or is it just going to, we have to wait to see what the actual demand is going to be?
I haven't looked into it, but I mean, I would guess if you're going to talk about what's communicating versus non-communicating, I mean, it's going to be 60 to 70% because it's just unrealistic to think people are going to stay with that one non-communicating unit. That's not what's going to happen.
That's exactly right. And it's just nice to hear that. I didn't want to insinuate that, but that is my personal feeling that a very high percentage, I would estimate above 60% of the equipment that will be installed in 2023 is going to be communicating equipment. It's not a small margin like right now. We're somewhere in that 8% range. By next year, it's going to be an incredibly high number.
I agree.
Wow. Okay. Big, big, big changes.
So if we move to our heat pump lineup,
Mm-hmm.
this always gets grumbles when I'm teaching this class live, but our base tier heat pump, the RP14 and RP15 AZs, those are our base tier heat pumps. They are
Right.
two-stage scrolls. There isn't a single stage heat pump in our lineup.
So in your heat pumps, are they all control board driven and no contactors?
No, these have a contactor and a defrost board in them.
Okay,
So they
excellent.
have a defrost board and a contactor. And then, those non-communicating base model units are a two-stage unit.
Yeah,
The asterisk out there, we have one builder grade unit that is going to be offered at an 18,000 BTU, and it's geared for multifamily, right,
multifamily
apartment
only.
complexes.
Yeah,
But
it's
that's
good
not
to
going to
see
be
that there's an option.
mainstream. Yeah.
No, no,
And it's only in the 18,000 BTU, which is what you usually see in those buildings. So,
exactly.
and then you move to the 16 SEER2 heat pump, and that's that inverter driven twin rotary that we saw in the 15 and 16 air conditioner with the BLDC outdoor. Also could be run on a legacy control, but should be run on the communicating EcoNet. And then you
So,
jump to the 18 SEER2, and that's fully communicating only.
so
Go
tell me
ahead.
a little bit more about this twin rotary. So, is it inverter? Is it how's that staged?
So this one particularly will run from 45 to 70% on an inverter, and it's a single stage induction motor. It's not a three-phase motor like you see in the inverter-driven scroll. And
Okay,
then once it needs more than 70% capacity, it switches off of the drive onto a contactor, runs with a run capacitor, and it
slams in
runs at
100%.
100% till it finishes the call.
Man, there's a big change, and that's going to be in a mid-grade piece of equipment.
Yep.
That's something that we've not even seen in high-end equipment that I'm aware of.
I
So,
don't think so either. Parallel circuits, run capacitors, and contactors
yeah.
in a cabinet with a drive. It's going to be
Wow.
interesting.
Okay. I'm telling you, people think I'm nuts, but this is the reason that I do this. It's the reason I ring the bell going, I love you guys. We got to educate because we are not ready for this as an industry. And that's why we're here. We want to do that. We want to make sure that you're prepared because these are huge changes. These are not little things.
So, typically this time of year, I'm running around teaching classes, whether they're inverter or whatever. I'm getting 15, 20 people in a class if I go to a city and teach.
Yeah.
I taught a class in Tyler, Texas, which is a small
Yep.
Texas town, right?
Yep.
Just Tuesday, and had 90 people in a live class in person because they're figuring out what's fixing to happen.
Yeah, exactly. And we're hoping to be that path. We're hoping to be able to bring our manufacturers like Rheem straight to the audience, straight to our educators, our educational facilities, our leaders within the industry, our technicians and our students, so that we all have a better understanding of this stuff. Not once we open that first box and go, "What is this?" beforehand.
Yep. And then, it's pretty common practice today. Somebody will go out and buy a 15 SEER heat pump or a 15 SEER air conditioner and try to put it on an old coil.
Yeah.
And, I keep telling these guys, you got to keep in mind that these mid tier inverter driven equipment that we're putting out won't run on a piece of equipment that doesn't have E1 and E2, which means it's got to be a match system or it's not even going to turn on.
We just had a comment come in from Bruce. It says residential techs are going to be caught like deer in the headlights. Bruce,
Yep.
that's why we're here, buddy. And we thank you for joining us. And anyone that wants to join in this conversation in our chat box, please do, because these are the topics that we need to discuss. There's a lot of people out there going, are they serious? Are they real? Well, we're 100% real. We're here with David Brannon. A technical educator from Rheem, the manufacturer of the equipment. It doesn't get any more real than that, my friends. Now.
So the big reveal here. So how
Yeah.
do you make equipment that has broader ranges of airflow without getting a board that doesn't have 15 rows of dip switches on it, right?
Yep.
So the way that you do it is you just take the dip switches off the boards and you go to Bluetooth and an app. So this video introduces that app.
Oh, okay. So I might have to come back to that one here in a second. I think I've got that one loaded internally, and I don't think it'll play a video. So give me a minute and let me come
We don't have
back
to
to
play the
that one.
video if you don't want to, but it is a video that introduces the app. We can talk through it if we need to.
You know what? Let's do that. I tell you what I'll do. I will put a link to this. So in our post, so once we get done, I'll edit this, get it back up into YouTube for us, and I will put that link in there so that you come back and check that out. And then on LinkedIn as well, and probably on
Yep,
Facebook, I will add that on to the reminder for this class so that you have links for it. That'd be something
that'd
to
be
come
great.
back and dive into. Yeah, it's a good one.
So the big thing is, I carry these boards around with me on a training board just to show the guys in the classes when you move to this technology, it's not like we're saying you're going to have either option, right? We're
Right.
moving to this technology, we're embracing the technology. We've taken the dip switches completely off the boards. So the only way that you have to set this equipment up is with the app or with
Connected.
a communicating thermostat.
Yep. Another conversation I had today with a different person, we were talking about connectability of residential equipment. And when I brought up the notion of moving away from dip switch control and using only application connection, and that we should be in our institutions, in our vocational training centers, allowing these Gen Y and Gen Z students and technicians to have control of the equipment and to embrace the technology, it's really looked at as, when do I need to do this? And my reply is, 4 or 5
Yesterday,
months ago. Yeah,
right?
this should already be in our program. And so it is going to hit a lot of people unnervedly come first of the year. Not just one brand. A lot of different brands are following this exact same route.
Yeah, I agree. So it shouldn't be a shock to anybody,
Mm-mm.
you or me included, that you know 60% of the time the dip switches never get touched on a board, which means we've
Very
got a
rarely.
bunch of equipment out there not
Not
running
a,
like it should
not
run,
commissioned properly.
right?
Yeah.
So you put an app out there and no other way to do it. You're putting it in front of them. They have to ignore it, not to set it up, because the piece of equipment won't run correctly if you don't go through these steps. So
Sure.
you're saying, okay, set it up. It's time to make it run correctly.
Yeah.
But it's going to make faster, easier installation. Diagnostics are going to be better because we're going to have real-time sensor output
On
for
board.
every sensor that we've got on the board, right?
Yeah.
We're going to see pressures, temperatures, superheat, subcooling, inverter RPMs, amperages, voltages. I mean, it's going to put everything that you would pull your toolbox out right there on your tablet or your phone.
And that's
Easier
really the way that it
installation.
should be. To be able to have that connectability, if the system already has the components, why are we even using manifold gauges?
Right?
From the world that I came from, if I was doing PMs on commercial rooftops, I didn't use manifold gauges unless I was recovering. That was it. I didn't put gauges on to test things because I already had pressure transducers and temperature thermistors, and I could literally just connect, take a look at my system, and have a good understanding of how it's running based on temperatures and pressures. If we look
Yep.
at a manifold gauge set, what are we looking at? If we take any electronic manifold set or digital gauges, we're using 5-volt DC pressure transducers, very similar to the ones that are going to be on the piece of equipment. We're using our temperature thermistors, 2, 5, 10, 15, 50K, whatever they are. They're just a variable resistance thermistor that's reading temperature, and we put them in the right places. Now we've got superheat, we've got subcooling, we've got temperature differentials, all built into the equipment. So now we just need to be able to tap into it and see it instead of having to add gauges to it to get an understanding. It's already there.
Yep,
Beautiful.
and then we've got the fan motors that have the technology built into them to where we're displaying, motor RPM and a static pressure off of a math formula on the app and on the thermostat. So there's no more, I don't know how to use a manometer, right? The static pressure is there. Now you still need to figure out which side of the system is the problem if it's a
Right.
problem, but you're at least seeing, hey, I've got an inch of static on this thing. That's not normal, or it shouldn't be.
So which pieces of equipment are coming Bluetooth enabled?
Everything from the 14 SEER up.
All of our mid-grade, all of our high-grade equipment
Yep.
are commissioned with Bluetooth, reading static pressure from
So
a
to
mobile
put that in a
device.
little more reality, right? We've got three single stage furnaces, an 80, a 92, and a 95 with constant
Hmm.
torque motors in them.
Yep.
Those are the only three furnaces in January that aren't Bluetooth.
So that brings out the whole other layer. When we talk about increasing the technology in a piece of equipment, we've been primarily talking about our air conditioning and heat pump side of things, right? Our SEER2 ratings, M1 testing for our outdoor equipment and our indoor coil matchup. Haven't really dove into what's happening with furnaces. And this is the beautiful thing to think about. If we are already communicating with at least three-fourths of our equipment, why don't we just add it into our furnaces and air handlers the same way?
Yep. That's our thought process. Make them communicating too.
So we'll be able to do diagnostics of our outdoor unit as well as our indoor unit, all from one location, looking at temperatures, pressures, voltages, current
Yep. So
draw.
this example is an outdoor unit. So we're seeing, AC input voltage, total unit current, compressor current, what the board's doing, hold off timers, EXV positions if we have them, and then saturated pressures and temperatures live on
I
your
don't,
phone.
I don't even know what to say, but I am so grateful. And I know there's going to be people that will just go, this is horrible. This is the worst thing ever. But when you take a minute and you step back and you look at the advances in technology and you understand the impact that this will have on efficiency and performance of our HVAC and refrigeration equipment, you'll get a better understanding of why. It's a drive for efficiency, and it is possible. We've always looked at efficiency going, blah, it's going to be very expensive. It's only going to be in the high end stuff. Well, now we've moved it into it is a majority of our market. And yeah, interesting place to be.
Yep. So we're going to be able to pull fault codes off, obviously, and we're going to have logins and things that are password protected because we don't just
Sure.
release all this information to the general public. So to pull the fault code, descriptions off of my Rheem, you would have to have a login. But you go to the piece of equipment, you pick the serial number, you run diagnostics, it gives you the fault codes.
Wow.
Also in real time, you can clear them and look at the history all from the app.
And so is it doing any kind of time date stamping on any of the history?
Yeah, so all the fault codes would show a time and date stamp when you looked at the history on when it threw it, what day, what time. So we get
Wow.
into, you know, part load troubleshooting, time of day troubleshooting.
Sure. Oh, by the way, what time do you get home every day? Because I see a spike in pressure at about 4:30 p.m. every day. How long is
Yep.
that garage door open when you get home?
Yeah. Or the
All
kids
right.
get home at 3:30 and leave the door open, completely
Yeah,
open. Yeah.
exactly. So onboard diagnostics are something that have been growing in our equipment for a few years. It hasn't been the predominant factor in our equipment, and I'm not really sure. I think if we step back and we look at it, it's probably because it hasn't been well educated on by our technicians, because it's been around for a little while and not utilized because people didn't understand exactly what it's doing. Now we can put it into perspective. We can say this technology is going to be able to make you a better technician. It's
Yep, I
not
agree.
here to slow you down.
No, it's here to make it faster. In the contracting world, time is money, and this is going to make it faster.
Absolutely. One of the questions came in, does it give you a snapshot of the running condition at a fault? It probably doesn't do that. It probably just throws the actual
No, I mean,
fault.
it would if you were making a spreadsheet out of all the data, but you'd have
Pull
to
the
be on
data
site.
points.
Yeah.
Exactly. Really, really, really cool stuff. It does bring up one thing though. Is there a way to track any type of data off from a piece of equipment? Because we see that a lot in our commercial industrial, but you would have to be tied onto a system, connected in some way.
So in this initial rollout, there's not going to be, data logging built in, but we're
Mm-hmm.
testing onboard prognostics. So not just diagnostics, but prognostics. So forecasting a problem. And once that stuff starts rolling out, it will be data logging.
Music to my ears. All right.
So this, the technology we're talking about with BLDC motors and boards that are manufactured by us. So if we had a supply chain problem, we could have that built by somebody else, or Getting rid of data cards, which lives primarily on our current communicating equipment, and not having to do that, and using Bluetooth apps to program that data into the board, so the boards only come partially programmed, which means that board would fit, 7 or 8 units, and you program it the rest of the way when you get to the piece of equipment. So it's not just setup that you have to have or diagnostics, you have to have this app to service the equipment as well. So control
Right.
board changes, compressor changes, motor changes all have a commissioning portion that are Bluetooth to the board to change the component.
Now, does it collect or stamp any of that or give you the opportunity to put notes along the way? Because this could be a phenomenal tool for a service company.
It probably will eventually. Right now, with
Mm-hmm.
these, if let's say we change a board, or you change, let's take a fan motor, for example. We take a
Mm-hmm.
fan motor and it's not the same manufacturer fan motor that was in the unit when it was built.
Mm-hmm.
So the motor would come with a tag, and you put the tag with a QR code on the inside of the electrical panel. So the next technician that comes along knows now it's using this motor.
Gotcha. Okay. Yep, that absolutely makes sense.
Compressors, it's going to log serial numbers. So you scan the compressor, scan the unit. It marries the unit compressor serial numbers together. And now you're tracking warranty. So you know when that compressor was changed and all that kind of stuff. So
That's
it is doing
exactly
it.
where I was going, but for the
Yep.
warranty aspect.
Yep. It is.
So we're just simply scanning our QR codes that we've had on parts. A lot of people don't realize this. We've been using QR codes on parts for at least a decade now.
We
Many
use them in the
people look,
factory all the time, right? It
yeah,
tells us what motor and compressor went in what unit.
absolutely. Next time you go get a part from the part supply, if you're talking about an OEM part, next time you get that, take a look at the part itself, look at the label, and you'll see exactly what we're talking about. So it's not like we're implementing a new procedure. We're just taking advantage of something that's already been implemented from the manufacturing process.
Yep.
Great, great, great opportunity. Wow.
But,
Lot.
somebody who's not been educated in this, that is going to make it where you go to the supply house, you buy a board for that new heat pump, you
Yep,
don't program the board, the unit won't turn on.
exactly.
Board's partially programmed, not fully programmed.
Just a base code. The beauty of that, this is a really, really, really good topic to just brush on. The beauty of doing a control board that is not specifically programmed from the manufacturer is it allows us to be able to manufacture a board that can be used on multiple capacities of
Right.
systems. So we can have one board for one entire model or generation of equipment, and all we really have to do is tell it what it's being connected to. So that has been a progression of boards over time. There was a period of time when we first started looking at that where we had pre-programmed chips or
Yep.
mods that we
Data
could plug
cards or
onto it.
daughter
That,
boards. Yep.
yeah, something that would be able to give that board some control. Now we're simply talking about all I need is cellular service, and off we
Not
go.
even cellular service, just Bluetooth, because all of these program files live in the app. So if you
Okay,
download the app, you don't have to have cell service
no cell
or
service
Wi-Fi.
required. Completely
Yep.
makes sense. So all of the data lives within the mobile app.
Yep.
Man, oh man. Beautiful, beautiful, beautiful stuff. I have a ton of questions, but I want to leave that alone because we've got people in the audience that may have some things that they want to check in. So I'm going to leave it open. We've had some great comments out there. Um, and it really is an opportunity for us to learn more from the people of the industry that have the firsthand knowledge. That was the reason that we started this entire show, is we knew that things were going to change in our industry. We know that there's going to be a lot of information and probably a lot of misinformation along the way. So why not organize the best people in the industry to talk about things from their perspective with firsthand knowledge? So you're coming straight from the source on these changes. So grateful that you're all here. If anyone has any questions, now's just a time to hop in over on the chat box and the message and give us a shout out. Anything else, David, that you'd like to cover? I'm sure there's a lot of heads out there just going, I don't even know what to do with this. Uh, One of the questions: does this equipment only accept OEM replacement parts?
I mean, for the near future, you would have to say yes, right? Because there's just
Right.
nobody out there on the aftermarket that's making anything like this. But
No.
that's not our intent. Our intent is to make it to where you can carry one motor and one board and fix several of our units without having to keep a truck full of stock.
Exactly.
Um,
I have
I
had
guess
some conversations with some replacement part manufacturers that have been preparing for this in the future, primarily motor manufacturers that are wanting to work with OEMs on programs and things to mod and test. So, like everything, there are going to be parts available. And the beauty of programmable parts is now it's less stock. If you think about how many motors, have you ever looked at a catalog to see how many motors are available in a motor manufacturer catalog? Tens of thousands of different models. Now, when we're talking about a manufacturer using a programmable motor, we're not talking about having 100 different motors from a manufacturer. We're talking about having a much smaller inventory that can be programmed for the piece of equipment that is going into.
Yep. So that's the goal, less SKUs, more range, being
Yes,
able to fix stuff easily, faster, not keeping our distributors from having to stock so many SKUs.
exactly. And, on that topic of flexibility and capacity and expansion, one thing we might want to brush on is half-ton increments, because when we start talking about inverters, now we're talking about pieces of equipment that can span larger capacity ranges. So is there even a need to have half-ton capacity units?
So we'll only have a few half-ton units in our 14 SEER range. So there's a 2.5 and a 3.5, if I remember, and there's a 1.5.
Right.
But they're, as far once you get up into the inverter-driven equipment, those are whole sizes. There's no half.
Exactly. Man, this is some good stuff. This is the kind of material that will linger for a long time, because I'm sure people out here are going to have to come back and go, wait, do you know what I just heard today? Have you heard this? And they're going to go, what are you talking about? And we go, well, we have a great source for that. So, other
Yeah.
topics that they can come back to, we've got EWC zone controls. By the way, do you guys on zone controlling, are we doing anything with zone controlling? Since
Yeah,
we're
so
talking
we have
communicating.
EcoNet zoning, and actually EWC builds our zone control for us, but it's not an off-the-shelf EWC. It doesn't function the same way. But we have an EcoNet zoning that's built directly for our communicating system. So the zone controls and the main stat and the board all talk to each other. It's full communicating, modulating system.
Nice. Had one other question that did come in. Question was asked that they had heard that if you push in the contactor on one of these modulated systems, you can do damage to the control board. Is there anything that could be spoken about that?
Well, we don't want to get too far in the weeds on that, but
No.
what they're talking about is this has technically has a parallel circuit between where the contactor and the run capacitor go to the compressor and the drive goes to the compressor. It's either or, right?
Yeah.
So if they were to have the system running on a low stage on the drive and they took the cover off the contactor and pushed it in, yeah, board damage would occur. But I
Sure.
mean, I don't know
Why? You got a
in
mobile app.
reality why you would do that. Yeah.
Sure. And it's just a matter of training for the differences. If we talk about service if we talk about some service techniques that have been used in the past on single stage contactor driven air conditioning and heat pump equipment, if you're wanting to fire up a system, check amp draws, just check basic operation of the thing, you push in the contactor. Never advised, actually. Well, now we have the ability to, well, what are we going to do with it? Let's turn it on. And by the way, we're just going to turn on the entire system. Since I'm out here outside, I'll just fire up everything out here.
So you can actually put these systems in charge mode, which locks the indoor fan and outdoor fan to a speed and the compressor to a speed with the app from outside without going in the house, right? One
Yeah,
button, it runs. There's also a test mode button on the boards. And, realistically, if we talk about how the system works, there's no troubleshooting benefit at all to pushing down the contactor. The
no,
compressor's not going to run, the fan motor's not going to run. So if you push it down while the system's not running, no damage will occur. If
yeah,
you push it down while the system's doing something else, then obviously that's going to mess it up.
yeah. Okay. Well, you got my brain going. This is why
Hmm.
we do this.
Right?
This is the reason that we spend time doing education on new technologies. It's not to scare people about the industry and where we're going, it's to prepare ourselves for these things that are coming. One other thing that I did want to ask about, is there anything in the realm of ductless and single and multi-head equipment in the future?
Oh yeah. So we've got ductless on the market now, and we've got
Hmm.
what I guess people are billing as universal heat pumps coming out in probably mid-July. So we'll have A side discharge that goes on an air handler, rated
Mm.
capacity with match systems,
Hmm.
but it could be ran with a different indoor coil if it
Sure.
needed to. So suction pressure control.
Yep.
The key thing there is, you don't have rated capacity unless it's a match system
Exactly.
with
So it's
any
a
of them, not just ours.
potential for an equipment replacement, but really
Yep.
designed for a system replacement.
And so we'll have ductless
Yeah.
stuff available in that line as well. And, we've recently acquired Friedrich Air Conditioning, so
Hmm.
we own them now. So we've got ductless through them as
Through that
well.
line. Sure.
So I would
Absolutely.
imagine in the future that those lines will
Expand.
mingle.
Yeah. All right. Well, let's give it another minute here. Anybody have any questions before we dive off from this topic? And I will definitely follow up with that video. I'll put it as a link into our YouTube cleaned up version of this. You can go to our YouTube channel at ESCO Institute. You can hop on LinkedIn, where a lot of you are probably at right now, which is HVAC Excellence, or ESCO Institute. And David, where are some other good places, some good resources for everyone to follow up with more information besides just what we've shared today?
So all of our industry regulation updates are on Rheem.com, and it'll be HVAC No Zone, KNOWZONE. So we've got all the industry regulations up on there. So the A2L changes, the M1 changes, and any other stuff that's coming from the government driven side of the things.
Awesome. Awesome. Well, David, I know you're on the road traveling. You're doing classes today. You're in an attic today, of all places, and took time to stop,
Let's
join
not spread
us.
that rumor around.
I know, man. I tell you, it's part of it. As much as we like to leave those places, and we try to leave those for the the younger whippersnappers, sometimes
Yeah,
we just have to.
you never get away from it.
You never do. And really, when we look at this industry, it kind of becomes part of you. Even though we have been in the field and we've started moving into the educational realm, it really is just about being in the middle of the industry. It's about teaching people the things that we have seen and understanding the things that are coming and joining as a group to better educate our entire industry.
Oh
So,
yeah, for sure. I grew up in the ranks. I'm still a licensed contractor and a master electrician in Texas. So,
awesome.
I've been in the industry since I was 13 years old. So nothing really changes. It just you grow with the industry and it grows around you.
That's exactly it. Growing. Man, that's a good analogy. We are growing together. Well, thank you everyone for joining Did You Know, the ESCO HVAC show, and we look forward to more intriguing educational conversations.
Thanks for having us, Clifton. We're happy to help anytime.
Yeah, we'll be back because we've got some more things to discuss. All right, everybody, have a fantastic rest of your day. Thank you for joining Did You Know, the ESCO HVAC show. You want to see some of these great presenters in person? Well, then we'll see you at the National HVACR Educators Conference, where many of these guests will be presenting live classrooms, and you'll have a chance to interact with them. Would you like to watch this show again? Hey, no problem. Just head on over to YouTube to ESCO Institute. Do you have a topic that needs clarified about some kind of a change in the industry? Well, then let me know. See Beck at escogroup.org and we'll see what we can come up with.